So we're going to jump into 3-4, section 3-4 from the book, which is systems of three equations and three variables. Okay. So first we're going to talk about an ordered triple. So an ordered triple is a solution to that system of three variables. And so it's written as x comma y comma z, right? So instead of having an ordered pair like we did when we were solving systems of two variables and two equations, x comma y, now we have an ordered triple. So we have three variables in the mix, okay? And so, yeah, so anyway, that's obviously one difference. So now let's just talk about kind of the evolution of our system. So first we started with just one equation, right? We learned how to solve one equation with one variable, like solve for x in an equation, and we would just get x by itself and solve, right? So if we just have one variable, then all we need is one equation to solve for that variable, right? But as soon as we put in an equation with two variables, like let's say 2x plus 3y equals 5, we can't just solve for x or y with just this one equation, right? We can get x in terms of y and y in terms of x, but we can't get any one isolated and equal to a single value, right? So what we needed two equations, right? So when we get to two equations, then we can solve equations with two variables, right? And that's what we did in the last lesson, where we solved system of equations by substitution, elimination, graphing, using tables, etc. Now we're looking at situations with three variables. We're going to have equations with three variables, and we can't solve that with one alone. We can't solve it with two equations alone. We have to solve it. We have to have three equations in order to solve a situation where you have three variables. Okay, so and this list goes on. So if you continued, if you had four variables, you would need four equations and so forth, right? All right, so there are a few ways to do this, just like with systems of two variables. We can solve by, the graphing would be difficult because these are three-dimensional lines, and so you need a three-dimensional coordinate system and a three-dimensional graph. Your calculator won't be able to do that. So it's something that you can maybe conceptualize by graphing it out on paper, but it'd be a little bit of a challenge. And so anyway, so graphing is tricky in that respect. So then you could use a table, but you'd have to match up three variables, right? So it's not just knowing when you have a match between x and y. Now you have to find a match between x, y, and z. So that becomes a little more complex as well. So then we have our algebraic method, right? Or methods, right? We have substitution, elimination. Put a little s there in parentheses. So we have substitution, elimination. And those obviously are going to be a little bit more challenging too with three variables, a little more time consuming, a little more work, but those are doable. So I'm going to show you how that looks, and then I'll show you a little shortcut or a method we can do on our calculator that makes it a little bit easier, and we'll start to get into a concept called matrices. All right. So anyway, the algebraic method. So we could use substitution or elimination. Usually elimination is a little better with these, especially when everything's aligned like it is here with our x's, our y's, our z's, our equal signs, and our numbers, right? Everything's aligned. And so now the tricky thing here is we have three equations. So when we do elimination, we're going to have to do two at a time, combine two at a time. So let me start by combining these two, because obviously the z's cancel out or eliminate. And so that's why I'm going to combine those two, is to eliminate the z's. So what's going to happen when I combine those is I'm going to have these 3x minus x. Those are going to combine together to make 2x. So 3x minus x is 2x. Then I'm going to combine the y's. Negative 2y plus y is negative y, right? Negative 1y. So I'm just going to put negative y there. The z's cancel out like we mentioned. Then I'm going to bring over the equal sign, and then 1 plus 2 is 3, right? So that's what I get when I combine these first two equations. All right. So now I have a situation where I have two variables in an equation. So if I can combine two of these other equations and cancel out the z again, then I can have two equations and two variables, and that's kind of what you want to do. So it's kind of almost, the first step is get down to two equations and two variables, and then you can use one of our methods to get down to one equation and one variable, and so forth. Okay, so the other two that I want to combine, or the other combination of two of these three, right? So I have to use one that I already used with this one that I didn't use, right? So this has a 10z. So if I want to get down to x and y, I have to eliminate this 10z. So what I'm going to do is I'm going to take this equation, since z is already negative, and I'm going to multiply it by 10. Okay, so I'm going to multiply this equation by 10, and I'm going to bring it down here. So it's going to be negative 10x plus 10y minus 10z equals 20, right? So I multiplied that whole thing by 10, right? So when I combine these, what I'm going to get, and I'll write it right underneath this one, is 5x minus 10x, which is negative 5x, 2y plus 10y, which is 12y, positive. The z's cancel out, which is what we want to happen, right? And then 39 plus 20 is 59. All right, so now we're gonna take a look at these two now. So now we want to use either substitution or elimination, right? We could isolate the y and use substitution. I'm going to stick with elimination. So I'm going to multiply this top equation by 12 because I want to get this to be negative 12y. I could also multiply, the top by 5 and the bottom by 2, and that would work as well. But let's go with the way that we only have to multiply one equation. So I would get 24x minus 12y equals 36, right? So I just distributed this 12 to everything there. Okay, then on the bottom, I'm just going to keep it the same. Negative 5x plus 12y equals 59. All right, so now we can combine these together. The y's will cancel out, and so I'll get 24x minus 5x, which is 19x, and 36 plus 59 is 95. So I'm going to divide both sides by 19. Now I'm down to one variable, one equation, right? And so we get x equals 5. All right, so now we have x. So now we have to plug that back in and find y. So we want to use one of these equations, right? Because we only have x and y there. So, or you could use this one actually, right? A modified version. So I'm going to use this one here, just because it has smaller numbers. So I'm going to go 2, plug in the 5, minus y equals 3. So I get 10 minus y equals 3. So we're going to subtract 10 from both sides. So we get negative y equals negative 7. And then we divide by negative 1. So we get y equals 7, right? All right, so far, let's start listing in our ordered pairs. 5, 7. You don't always find x first and then y and then z. Like, this is just coincidence that happens. Sometimes you have to find z first. That's the most convenient. And we could have actually chosen to find z first or y first if we wanted to. So it kind of the order just depends on, how the problem, what the problem lends itself to, and so forth, how it's set up. All right, so now we want to find z. So we can pick any of these equations with z in it to find z. So I'm going to pick this first one because z is positive. So I think it'll be the easiest to isolate. So I'm going to go 3. And then for x, I'm going to plug in 5. For y, I'm now going to plug in 7. And then we're going to be looking for z. Okay. And so we'll get 15 minus 14 plus z equals 1. So 15 minus 14 is 1. Subtract 1 from both sides. So we get z equals 0, right? So 0 is our third coordinate. And that's our answer. So 5, 7, 0, or x equals 5, y equals 7, z equals 0. So that's the algebraic methods. You can see it's a fair amount of work, right? It's almost like 3 times or more doing substitution or elimination with two equations and two variables. So I think you hopefully agree that maybe we'll look for a better way, more efficient, faster way, right? But this is a good, I wanted to show you this just to show you that our algebraic methods work in case you're in a situation where, you're on a standardized test, or in a situation where you just don't have a calculator available, or you're not allowed to use a calculator. This is how you would do it.